In this question, we're once again asked to find the area bounded between two curves. A great place to start with these questions every time is to try and get a rough sketch of what these curves look like, especially when they're functions that are pretty familiar to us. So in this question, that's exactly what we have. The first one I'll draw in red. Y equals x squared minus 4 is a parabola with vertex at 0, negative 4. So somewhere down there, and it's just your basic parabola. That should be no problem. I'll draw the next one in green. Y equals negative 3x squared. The negative coefficient in front means it's a parabola again because it's x squared. The negative means it is facing downwards. The vertex is still 0, 0. We haven't shifted away from that. So it's going to look something like that. Again, these are very rough sketches, but it gives you an idea that we're clearly finding this area in here because it's the area bounded between these two curves. Great. So we're after that blue area. You can see that this is a good one to do vertically. The reason that is because as you go left to right through the area, you can see the green function's always on top or acting as the roof of the region, and the red function is always acting as kind of the floor. You can draw vertical lines all the way throughout the area, and you'll always hit the top being the green and the bottom being the red. So when we do that, we know we're going to say the area equals the integral from x equals a, so the far left point, to x equals b, the far right point, of the top function, or the roof, minus the bottom function, or the floor. And since we're going to be moving left to right in terms of x, we want to differentiate these with respect to x, so we'll write a dx there. All this means is that we're going to take the top function and the bottom function and write them in terms of x, as opposed to in terms of y, where we sometimes go from the right side to the left side. Okay, so now we're almost all set. The last thing we really need to do is figure out what this a and b are. In other words, where we have to tell the integral where to start from the left and where to finish on the right. To do that, we need these points of intersection. We can either sort of use mental math to guess, or if we want to know where these two curves intersect, we just set them equal to each other. So x squared minus 4 equals negative 3x squared. Bring everything to one side and we get 4x squared minus 4 equals 0. To find where they intersect, let's factor out a 4. X squared minus 1 equals 0. And finish factoring, this is x minus 1, x plus 1. So we can equals 0. So we can see the answer to this bracket being 0 would be x equals 1. The answer to this bracket being 0 would be x equals negative 1. And that is exactly where they meet, right? This point here is where x is negative 1. This point here is where x is positive 1. Those are going to be our limits on our integral. So let's go ahead and solve. So it's the integral from negative 1 to 1 of the top function is the green one. So negative 3x squared minus the bottom function, which is x squared minus 4 dx. Great, so now let's just simplify this. So integral from negative 1 to 1 of negative 3x squared minus x squared plus 4. Don't forget to run your negative sign through there. Dx equals negative 1 to 1 of negative 4x squared plus 4 dx. Okay, so now we're actually ready to integrate. I'm going to erase and then we'll continue. So I will move up here now. To integrate negative 4x squared, you focus on the x squared part. To integrate, we go up a power and divide. So instead of x squared, it's going to be x to the 3 and divided by 3. The negative 4 comes along because it's just a constant. Plus 4 becomes plus 4x to the 1 divided by 1. So plus 4x. It's a definite integral, so we're going to evaluate from negative 1 to 1. This means we plug in 1 for each of them, then subtract plugging in negative 1. So it's going to look like negative 4 times 1 cubed over 3 plus 4 times 1 minus, and now we plug in the negative 1. Careful with your signs here. Negative 1 to the 3 over 3 plus 4 times negative 1. Now we just, again, careful with our signs, we get negative 4 over 3 plus 4. Inside the bracket here, we're going to get positive 4 over 3, so it's minus 4 over 3 when we run the negative through, and we'll get minus 4 inside, so it'll be plus 4. In other words, we get 8 minus 8 over 3, or if we want that as one fraction, it is 16 over 3. And that will be units squared because we're talking area. Okay, so in terms of steps, look for a common roof and a common floor. That will tell you want everything in terms of x. Set the equations equal to each other to find those points of intersection, and that sets up your limits on your integral. Hopefully you found this helpful. There's another video going side to side when we get the functions in terms of y, but you can always send us more questions, info@arnoldtutoring.com. Thanks.